In this video, we're going to talk about some more properties of logarithms. So if you were not here on Friday to get the introduction to logarithms, you probably will want to get that information first. So we're going to start by looking at the change of base formula. Now this information is on the sheet that we looked at on Friday. You use the change of base formula if there is a problem that you cannot easily evaluate with some common exponent rules, or perhaps you're trying to graph, which we will do in a few days on your calculator, and you're trying to graph a log of a base other than 10. So the change of base formula that we will use initially does this. So if you have log of a certain base equal of a certain quantity, you can rewrite that as log, and that's the common log of that quantity over log of the base. So you're using the common log, which is base 10, and you're essentially rewriting that logarithm as a ratio. Later on, we'll learn about an additional log that you have on your calculator, but right now the only log key that we use is the common log key, or the log base 10 key. So to use this in practice, if you have a problem like log base 64 of 16, you rewrite that as log of 64 over log of 16. And you can key that into your calculator, and when you do, you really come up with the value of 1.5, or as a fraction, that is 3/2. Now again, what that means is you're thinking, okay, log base 16 of 64 equals 3/2. So that means 16 to the 3/2 power equals 64. And if you think of flower power, that means the square root of 16 cubed equals 64. So this is really beneficial when you're trying to find that power that is a rational power or a fractional exponent. And sometimes you just don't get nice values, so to speak. So that's essentially all you're doing. Log, for example, the next one of 32 over log of the base, which is 8. And when you enter that in your calculator, make sure you close your parentheses correctly. You get 1.6 repeating, or 5/3. Since that decimal doesn't terminate, I would personally rather you use 5/3. On 23 down here, log of 54 over log of 2. And that you really just get an irrational number. It's a decimal. That's equal to approximately 5.75. So again, as we're doing these, just make sure that you're able to set these change of base formulas up correctly and get the appropriate value using your calculator. So that one would be irrational at approximately 2.47. And tonight you won't have any additional homework problems. I just wanted to make sure that you were introduced to the change of base formula, and we will practice a little more the next day in class. Now on 26, really you should be able to do that one without the change of base formula, because you're thinking to yourself, okay, 6 to the what power gives me 1 over 36, and that would be 6 to the negative 2 power. However, if you're having a moment, a brain lapse, you can use, again, the change of base formula, log of 1 over 36, and since that's a fraction, I would make sure to really watch my parentheses there, over log of 6, and you do get that exponent, that value of 2. So the next three properties or rules, if you will, are new to you today. They're on the new piece of paper from today. And you use these to expand or condense a logarithm, and you will do some expanding or condensing just depending on the situation when we talk about solving logarithmic equations. But the product rule, the product property says this: if you have a log of a certain base of two things being multiplied together, or a product, you can separate them out using addition. Log base b of m plus log base b of n. And the base is the same on each of those terms, and you're just going back and forth depending on what the situation calls for. So on the next three examples, you're condensing into one log. So if you notice, you've got two logs being added with the same base, so you can condense those together using multiplication, and then whenever you can, go ahead and multiply those values together. And they're all very similar. It doesn't matter if it's a common log or log of a different base. If you've got two logs that are being added together or added, you can put them together using multiplication. And that one there, you can actually simplify a little more, because if you remember, the base of the common log is 10. So you're thinking to yourself, 10 to what power gives you 100? Well, that would be 2. So continue to simplify as much as you possibly can. On this last one, log base 4, you've got some variables in there, but you treat them the same way. You just multiply your quantities together. So that will be log base 4 of 8x cubed. Now, the next ones, as we expand or break apart, I'm not going to worry as much about these two examples, because really the answers can vary as far as what numbers you're choosing to multiply together to get 6, or what numbers you're choosing to multiply together to get 45. But on this last one, when you have log base 2 of two things being multiplied together, to expand that, that means you're going to bring in the addition, so you'll have multiple logarithms. So that becomes log base 2 of 5 plus log base 2 of x. So whichever piece of the product is first comes first in your sum, and whichever piece is second, again, comes second in your sum. So that's the product property, or the product rule. The next rule is the quotient rule, or the quotient property, and it's very similar in that if you're taking the log of two things being divided, or the log of a quotient, you can expand that or separate that out by saying log of that base of whatever is on top minus log base whatever is on the bottom. So log of the top minus log of the bottom. So when your instructions tell you to condense into a single logarithm, you're kind of using this property in reverse. So you currently have two logarithms, and you want to go to where you just have a single log. So you're going to take those that are being subtracted and condense them using division. So that will be log base 3 of whatever is on top divided by whatever, or divided by the second piece goes on the bottom. So if you've got log base 3 of 24 minus log base 3 of 8, you can condense that into log base 3 of 24 divided by 8, and that becomes log base 3 of 3. And actually from there you can continue, because if you ask yourself, okay, base 3 to what power gives me 3? Well, that will be the first power. But that piece is what we talked about on Friday. That second problem, again, two logs being subtracted, you put them together using subtraction. You put them together using division, or by creating a quotient. Now, if you see the big picture, really, if you see that these two things are the same, that quantity does give you 0. But just to show you that the rules are working as they're supposed to, you would have log base 2 of the first value divided by the second value. So that's log base 2 of 1. And again, you're thinking, okay, 2 to the what power gives me 1, and that power would be 0. And then finally, we have some variables. So if you've got an expression that you want to condense into one log, the base will be 4. And whichever log comes first, well, that goes on top of the quotient. That's the numerator. And whatever log comes second, that piece, that term goes in the bottom or into the denominator. And then make sure you simplify. So log of x to the 9th over x squared can be condensed to log base 4 to the 7th x to the 7th power, because you can subtract those exponents. And again, I'm not worried about number 10, I'm not worried about number 11, because those answers will vary depending upon what numbers you choose to incorporate. But that last one, number 12, that's the common log, but that's okay. You do the same exact thing, except on this example you're wanting to expand. So that means you're wanting to break that one log into several, or 2, I guess, pieces. So you say, well, I've got log of my numerator minus, because we're dealing with division or quotient, log of my denominator. And your base would be 10, but since that's the common log, we don't express that. And the last rule or property is the power property. And what that says is if you have log of a base of some quantity that has a power, you can move this power around to the front. So that's equal to n times log base b of m. And again, you'll use these properties when we start to solve equations. So again, this power that's in front to condense just gets moved around to the back. So that's log base 4 of 2 to the 5th power, or log base 4 of 32. And that's really all there is to it. This 7 in front gets moved around to the back, so that becomes log base 2 of x to the 7th power. This 1/3 gets moved around to the back, log, it's the common log, of 8 to the 1/3 power. And you could also write that as log of the cube root of 8. And if you think about the cube root of 8, well, that's just 2. So really, you can write that as just log of 2. So continue to simplify as much as you possibly can. When you expand, you're just doing the reverse. You're bringing that power around to the front. So that's 7 times log base 2 of 8. And actually there, you could think, okay, 2 to the what power gives me 8. Well, that would be 2 to the 3rd power gives me 8. So 7 times 3 would be 21. So continue to simplify as much as possible. Even if you have multiple terms in your exponent, again, this is just going to come around to the front. And since there are 2 terms, I will put that in parentheses. And then that's going to get multiplied by whatever is out there to begin with. Then I'm going to go ahead and distribute, so that would be 3x minus 3. I'm going to keep that all in parentheses because that whole thing will be multiplied by the log of 4. And then on that last one, we're going to kind of do what we did on number 15. You need to create a power from that square root first. So that will be log base 7 of w to the 1/2 power, if you think back to the last unit and the flower power properties that we used. So now this power, using our power rule, can be moved around to the front. So that's simply 1/2 times log base 7 of w. Now, that wraps up the front side, kind of as an introduction to those properties. On the next video, we'll go over the back of your paper just for some more practice on putting all 3 of these properties together.